The arbor support is finished and it's working great. This was a big project, but there are a couple of other smaller projects concerning the mill that need to get addressed as well. And so this video we're going to knock out some of those. We got the pulley off of the spindle side. It comes off by loosening these three socket head cap screws, and then you will open up this split just a little bit and it will release from that tapered part. Probably a good idea not to remove these completely, because once I got this split a little bit, the wheel came off right away and I had to be quick to catch it. But there's a last time for everything. We want to remove this overarm. I've loosened up these bolts already, and this hasn't been out in ages, and possibly since the day it was assembled, so I don't expect this to just slide right off. I think I'm going to go about this a little differently. There's this spot here in the middle where it's been welded together, and I don't think that's original, especially because I didn't see anything welded in the drawing, and I see some rather rough kind of grinding right on the top of it here. I'm being careful not to strike the overarm at all with the saw. I'm probably sawing through not just that weld, but decades of little chips stuck in this slit as well. So it should be coming out pretty soon. That might have been it just now. Yep. There it is. And of course it's hung up on the last little bit, but that's all right. Okay. You ever seen a Nichols overarm outside of the machine? Well, here's what it looks like. This is the short overarm. If I want to use longer arbors, I need a longer overarm. Just for fun, there's the original overarm. That's 20 1/4. Here is a piece of 2 1/4 diameter, same as the original. Keyless, no keyway cut in it. Piece of turn ground and polished shafting. This is 30 inches. So I should be able to absolutely run the longer Nichols arbors and maybe some, mid-length NMTB arbors meant for, other machines that have a longer overarm. Now let's see what's going on over at the machine. Okay, let's see how this goes in. There we are. Nice and easy. And there it's just a little bit proud of this side of the back, and I will definitely be able to use the longer arbors that I can find where I do. The original motor is back on, and I've got a VFD powering it now. This is how it's going to be arranged just while I'm kind of getting it set up. The motor is going straight to the VFD, but the plan is to have the VFD powering the original equipment that you can't see, but it's on the back of the column. And of course, in the end, we'll have an enclosure for the VFD. Originally, this mill had a safety switch with fuses, a thermal overload protection, and a reversing switch. I want to have these all connected if possible, or at least as many of them as I can. But back to the motor. We're going to do an oil change on this, because I'm sure the oil in here is pretty old. This is the dipstick, if I'm correct, if I got the location of this thing correct. Yep. And this is the type, I suppose, where the bayonet type, where if you see oil at the bottom, it is, it has an oil, it has a level of oil in it. I see just a little bit of oil here, although it's pretty dry otherwise. And the oil that is in there, and just, just a film of it on the dipstick is black. So we're gonna definitely get this old oil out. That was kind of just for fun. I'm gonna open up the one on the bottom and just let this stuff drain out. Although probably what I ought to do first, since we're changing oil on a motor, is I'll just let it run for a couple of minutes. Although what would be a good idea, I think, is I want to flush it out as well. And so I'm going to put in some, maybe like half a cup of kerosene in here. And that ought to slosh around and get some of that old disco dancing oil off from the gears and all that. We'll let this run for just a couple minutes, and I'll bring you back when we're going to drain it out. Yeah, that's mostly the kerosene. Anyway, I'll let that just drip for a while, and then we'll put in our new oil. Here's our oil. The Nichols manual calls for 40 weight oil, and this is non-detergent, so this is probably what they're calling for, really, as old as that manual is. I hope I'm not hurting anybody's feelings by using a can of vintage oil that someone would usually just collect. It's a vintage motor, and I paid less for 2 cans of this than I would probably 1 can of new stock oil. And if your feelings are hurt, well, I'm probably going to use this one too. How much oil? It's hard to say. The manual doesn't really tell me how much it ought to get, but we'll check the dipstick as I'm pouring. And I've got far more than I need. I've got 2 quarts of it. Before I changed the oil, I was getting some kind of clicking noises, some little noises from the gearbox, I expect. Let's see how that sounds now that we've got some fresh oil in there now. I'm hearing the gears, but I don't think I'm getting those other little sounds. I don't see oil flying around, so that's good. I think that's it. Okay, that's as tight as that's going to get. And it's on backwards too, I know. But I did not expect to get that back in there. Not that it was easy. You know, it's been actually a couple of years since this came off, and that was when I bought this mill. We pulled this out of the switch so that we could get the motor off. Fortunately, though, the drawing on the inside cover is still intact and in good shape too. Oops. And that's it for wiring this thing back together. Although there is still that. But that turned out to give us problems, so I've had to do it again. We blew the fuse. Got my switch going to forward. Let's see what we get now. Okay, so now as I'm turning the potentiometer on the VFD, okay, so before it was just slamming the VFD. Let's give this another shot here. Okay. I was hitting the start button after it hit, the VFD had already, you know, ramped up and gotten to the top of 60 hertz. And so at that point when I hit my start button, I was, you know, getting all the power all at once from the VFD. And that's why it gave me an overcurrent error. So let's see if I get an overcurrent error when I hit stop. No, I don't. I bet if I just hit start again, I am going to get an overcurrent error. Yeah. I'm going to have to change something about how the machine's electrical control is interacting with the VFD. This is the temporary solution to that. This knob is connected to a 2 kilo-ohm potentiometer with a wire running from it to the VFD. This will control my frequency, and the way I'll go about using this is I'll dial the knob up to somewhere shy of 20 hertz. Start the machine, and then bring it all the way back up to 60 hertz, do my milling, hit my stop button, and then ramp this back down to where I began, let's say 18 hertz. I can then start it again and, you know, ramp it back up, hit stop, ramp it back down, start it, and all that. Well, that's all the time I have for this video. You can look out for part 2 of this about next weekend. And this weekend I'll be putting out a video, a little bit of a how-to, so you might enjoy that. Catch you later.